This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So until last session, so we were actually trying to do kind of the CI/CD on the servers. So we have some idea, right? Now you try to understand so how much time it is taking to do the deployment, right? So the instance refresh is taking a longer time. Like let's say the number of instances you have, so it depends on that. It's a very longer time as well, right? Isn't it? It's not that quite simple. Okay, so now what I need to now what I need to do here is I need to not I need to basically, so we need to find out so a solution which can be we need to find a solution which can be done even a bit faster than that. Okay, so that's where so we need to look into some other solutions, which is containers. All who is solving the problems out there is containers. Okay, so and you want to reduce your efforts basically, and in terms of the deployments, and you want to make it a bit faster, and at the same time so in a better more process and all. So it's actually container technology, and that's where everyone started looking into the containers, and container is a lightweight one first of all, and that's where it's solving some certain problems. And yeah, so we are actually looking into that particular problems now. Okay, let me quickly take to okay, so we are going to talk about a container. So before I would say here, I will just say we're going to talk about so containers. Now containers, you need to understand so that containers are a lightweight basically. Okay, so what is a container, and how container works. Okay, so we need to understand that a little bit, and then we will move on to real practical things. So first one day or sometime, just going to be a little bit theory here. Okay, now how a container works first of all, or first before going to the container, so let's see how actually the infra has been evolved basically. So if we just look into the infrastructure or server evolution, so the server evolution happened, so from a physical machine. Okay, so physical server. Yeah. So this is a server. Okay, so yeah, let's say this is rack server basically. Okay, so here okay, all right, so this is the rack server. So from here, okay, so from here we moved on to the next layers, which is basically the virtual machine. So this is a physical box. Okay, rack server, and from there the industry moved on to the virtual machine. Okay, so virtual machine. So virtual machine is something like this. Okay, so you're having a single machine. On top of that, you're going to get multiple machines. So that's where we came into virtual machine world. It's not coming now. So just an easy way to understand, I'm looking for the art. Okay, I'll just use this only. So the next thing which we came here is in the world, okay, in the usage world, we got it is into virtual machines. And from there, now what we got into here is, we just got into containers. Okay, so like let's say, so let me take these pieces only. Okay, all right, I think enough of time. So now this is the evolution happened. Okay, so from so rack server, or if I actually put it on these also on the application layer. So here, virtual machine. Let's say physical server and virtual server. Yeah, here is the right diagram basically. Okay, all right. So now here in the virtual machines, so what you're going to have on the physical machine means one hardware you're going to have, and you're going to so have some operating system. On top of that, you're going to have some application. So that's it. Whereas coming to the virtual machines, so the virtual machines is something here, so which is okay, infrastructure you'll be having, and you're going to have, that means infrastructure means the physical box. On physical box, you're going to install some software, and that software actually you're going to get a simple virtual machine, and so on top of that you're going to install some operating system, and again you have some application and libraries. This is how you're going to get. Okay, now where is the security? Okay, let's go talk about here. So why I am actually trying to put these diagrams is, okay, so compute evolution, I'll bet in a more better way. Okay, so where is the security? Actually, you're going to a virtual machine, where is the security coming up? Okay, so where the security is coming up, so you have one virtual machine and you have another virtual machine. Okay, so how the security is actually, both are sitting on the same machine, both are sitting on the same box. Okay, so yeah, so that is the reason where the security comes into picture. Does anyone have some idea, like rough guess, just some rough point out as well? What is your understanding how a security you would be thinking it's coming? Okay, even it can be wrong, your point can be wrong. Let's try to just make some understanding. Let's try to understand what is your understanding, like anyone. Okay, so you have two virtual machines actually sitting on the same machine, physical box. How do you think the security is actually coming up into picture? Who does that particular part? If it is being secured, who is doing that particular part? Any rough guesses?
Maybe firewalls.
Firewall is a device which is outside of server, right? It's not server, inside server, isn't it? So
operating system.
So which OS basically? So guest OS or infrastructure OS?
Guest OS.
It's infrastructure OS. That is.
So guest OS is individual, right? So it doesn't have any relation here. So the infrastructure OS. Okay, and that infrastructure OS here you're calling it as hypervisor. This hypervisor software is the one who is responsible about managing the isolation. Okay, isolation of your hardware resources. Let's say you have some 16 GB of RAM. Let's say 16 GB of RAM. You're having this particular box, and this machine is using 2 GB, and this machine is using 2 GB. Let's say now the hypervisor software will ensure that that 2 GB will never be touched by this VMA. 2 GB memory will never be touched by VMB 2 GB. I mean VMB memory. Okay, if memory is overlapping, the memory is the place where actually all the transactions about your operating systems happens, right? So if that is actually getting overlapped, then you are, you can say that it is not you can say that it's not a secure, right? So it should never happen, that particular overlapping, and that's where the hypervisor software will provide that particular one. And it is proven, by the way. Okay, it's really not like so today's technology, it's been there and it's a proven one. Okay, so that's how the machines are actually getting isolated, and that's how it is secured, and everyone using this one. Now Amazon, if you go there and you're taking a server, so that means you get it on one hardware, and if someone also trying to take a server, it comes on the same hardware only, but the isolation will happen. And who takes care of that? The hypervisor. Okay, fine. So the security wise, it is okay. Next thing, coming to the container. Container, you're going to have the infrastructure, and you're going to have the host operating system. Infrastructure can be your virtual machine, or it can be a physical machine, doesn't really matter. You're going to have a host operating system, and you're going to have the containers. So you're going to have container A and container B. Okay, so so basically going to have container A and container B. And so these two containers, how these two containers are isolated now. And here you don't have a guest OS. What is the difference between a virtual machine and a container? You have apps basically in libraries, but not the operating system. Okay, operating system is not there. So that's why the container is lightweight. Okay, OS will not be there. In order to do the OS installation like a virtual machine, how do you do that? Okay. So that is the difference. That is the difference. Okay, now actually who is actually taking care of this isolation? So now not this Docker even, it's a container stack. Who takes care of this one is the host operating system. Who takes care of the isolation here? The host operating system. So that means you know, in order to have some container working, so what all the pieces you do require here is so if you want to make your containers working, so there are you know, there are two pieces which needs to be there. So the first piece is let me go a bit other way. So how containers better than this, I'll just make this first. And what I want to say here is okay, so containers, okay, so container is a Linux feature basically. Okay, containers is a Linux features. You know, Linux means I already talked about what is Linux. Linux is nothing but a kernel which drives the hardware and software. You remember that? So that's where you know. So container is a you know, Linux kernel feature basically. Okay, so that means it works only on it works only on Linux OS ultimately, right? It works only on Linux box because it's a feature from the Linux. Without Linux you cannot run a container. But yeah, so these Windows guys actually what they're trying to do is they kind of run some virtual machines in the background. Even Mac OS also supports the containers, but they kind of run some Linux things in the background. Okay, and from there actually they do some relation and make your OS level commands working. Okay, so whatever it is, if your container want to work, then there has to be a Linux feature basically. Okay, now okay, so Linux is the one who provides this particular so Linux kernel offers C groups, and C groups means what? Control groups. So Linux offers control groups and namespaces. Okay, namespaces and containers. Okay, run based on containers run based on this. Containers run based on these features. Okay, and containers security, container runs based on these features, and also security comes from these features basically. Okay, so that's how you just try to understand this, right? So yeah, so container is a Linux feature. Basically it works on Linux OS only. Okay, so Linux kernel offers control groups and namespaces, and so now I'm going to talk about control groups. So in shortcut, these are also called as C groups and namespaces. And why do you require them? Okay, just a little bit glimpse. Okay, you know, to really get in detail, but yeah, beneath the scene you need to understand how these are working also. This gives some knowledge. Control groups. What is a control groups? Since the name is telling that's a control, right? Okay, so containers capable of consuming all the resources of OS, So that means, okay, so let's say one container, you launch container A, container B. Container A can read the, let's say your host's operating system is 16 GB, whereas in the virtual machine you have a very limited way, right? So in virtual machine, you create a virtual machine with 2 GB of RAM. The scope is only 2 GB. The scope is only 2 GB. It cannot actually use a whole, so infrastructure, whatever you have. But whereas container A will use a whole infrastructure resources, container B also will use whole infrastructure resources. So that means if you ask container A, what is your memory? It tells you the 16 GB. And you ask container B also, what is your memory? It gives you the whole 16 GB. That means it has a capability of using the whole resources. Okay. So container is capable of consuming all the resources of OS. Yet we need to control. Control or limit the resources, and that particular part will be done by control groups. Okay, that part will be done by control groups. Okay, and so what is the namespaces is doing? So the name itself is telling it's actually trying to put some so spacing, and this is about controlling the resources, like limit the resources basically. And whereas this is to isolate the resources. Namespaces are meant to isolate. This is the security. Isolate the resources. Namespaces are meant to isolate the resources. Okay, so that is what you have. Namespaces are meant to isolate the resources. Okay, so that means it has like, let's say netns is a network namespace. For an example, just saying. Okay, so for example, netns is a network namespace, okay, which isolates the network for containers. Okay, so this is how actually you are going to get the containers up and running, and how do you isolate them, and how do you get the security basically. Okay, and this is the idea. Okay, so all right, this is fine. Okay, so okay, first of all, what is the need of this? Okay, fine. Okay, containers is too good, superb. Okay, but where is the need coming from? Okay, so why do you need containers? Okay, so that's what also we need to understand, right? So the containers are needed for compute basically. There is nothing much to talk, but it is needed for compute. Okay, so if you have some compute requirements, you can look for containers, and you can ship some software running out there, so it can just run that particular software. All right, and I'm just thinking about yeah, so when you say container, okay, so like so when you say container, so you have majorly three things which you are having. So which is Linux containers, or basically you can call it as LXC. Let's put very shortcut LXC. Linux containers you are having, and you are having RKDs. Okay, and the last one you have is Docker. Okay, so when you talk about containers, you have three major tech stacks basically. Okay, LXCs, RKDs, and Docker. Okay, so RKDs and Docker, and over here now, why Docker basically? Why Docker? Okay, you might hear about all the time, so why Docker? Docker, right? So Docker is famous, isn't it? And Docker is famous, and Docker is famous, but why? Okay, so but the question actually should be there, right? But why? Okay, that a lot of people actually even think like, so container is nothing but the Docker, and Docker is nothing but the container. No, so there are other technologies as well. So but the core features are the Linux features. Everyone uses the same features basically. Everyone uses the same features, but Docker is actually a kind of a famous one, but why? Okay, so the whole ecosystem of the Docker is quite simple. Okay, so that's the only simple reason I would say it is, or it is famous for two reasons at least. It is famous for two reasons. Okay, so simple ecosystem. Okay, that everyone will be able to, so work on that very simply. Simple ecosystem they have, the whole ecosystem is simple. And the second thing is, okay, so UX. Okay, so best UX. It has best UX. Okay, it has best, user experience basically. Just to add something, user experience. Okay, it's always about the user experience only. Okay, so I mean, you take any kind of, like, let's say, so Gmail, Yahoo Mail, Reddit Mail, so you go back 2 decades back. Okay, before Gmail there was Yahoo Mail, there was a Hotmail. Okay, there is Reddit Mail. Okay, lot of providers actually, even that time also those were there. But why all of a sudden Gmail came into picture and it spiked the market, so too heavily, right? So how do we think that, or what do you think that happened actually? The Gmail makes more users, rather than the other users. It's simply the user experience. Seriously, the user experience. Okay, so yeah, and that's the same thing story with the Docker as well. Okay, even though you have Linux, LXCs, basically the Docker actually try to do here is Docker used to have here is why are you getting this particular Docker as famous is the user experience. Okay, so simple ecosystem. Okay, the whole ecosystem of Docker is quite simple, and mainly the Docker imaging part is really simple and great. Okay, so Docker imaging is there. So how do you make some Docker containers? Is basically to run a container you require an image, and that imaging part actually Docker makes it quite simple. Okay, whereas you have other containers like Alexis and Archetis, it's not that simple, that what Linux actually offers. Okay, so that is the reason, or I would say this is one of the reason. Okay, the Docker is famous basically. So the simple ecosystem lead a lot of customers actually. A lot of customers actually fall because of its features, and one of the feature is their ecosystem basically. All right, and the next things is best user experience. Okay, so the next thing is best user experience. Just give me 1 second. Yeah, so the next one is best user experience. Okay, so user experience, so Docker containers are so simpler to manage, and simpler to manage, and what is the other major point is there, and even offers and extends its features to interact over API, and so interact over APIs. So Docker containers are very simpler to manage, so the options are also quite simple. Okay, and I think so every Linux container, every container technology also has the same thing. So there's no great point in that, but actually it extends its features over to interact it over the APIs as well. Okay, to interact it over API. So that's the core feature which we need because we want to manage centralized machines. So back in days, at least I started working on containers back in 2011, 12, that time. Okay, where we don't have a Docker also that time, but Linux containers were there. Okay, LXCs were there. So LXCs, if I want to manage my LXC, I have to log into that machine, and then only I can, if I log into the machine, then only I can make my containers running, or basically I can create some containers. But whereas if I go with what we call but whereas if you go with Docker, basically you don't need to really log into the remote system, so you can even launch them from the centrally. Okay, so that's a major thing. It even changes the user experience basically. Okay, so these are the two quiet things. Basically, I'll consider it as so the reasons why Docker is famous. Okay, you should have a reason, right? So why this is famous? Like let's say we say operating system. Why Linux is widely used in the server operating system? You should have some reasons. Just not like that we will be using it, right? So it should be having some reasons, and yeah, so some of the reasons around the Docker is these are the two reasons that is making it. All right. Yeah. And the next thing here is okay, so the next thing is here, okay, to start with so you understand the flow basically. Control groups, security, Docker. Yeah. And the next thing, so which I would like to talk about is okay, so basically, Docker brings immutability. Okay, so Docker brings immutability. Okay, you know that immutable infrastructure, right? So Docker brings immutability, and that is so from here actually the infrastructure actually started adopting the immutable options. But yeah, so here is where actually your immutability so here is where actually the immutability has been all started with. Okay, so yeah, Docker brings the immutability. So that means if you want to launch a new container, so the old one will be deleted and the new one will be created, or new one will be created and the old one will be deleted, but you will never modify the containers. Okay, you will never go into the container and modify the container, and you should not, even though you are capable of doing that, that's actually you're going deviating the technology basically. Okay, it's not really needed. Okay, so that's another thing so you need to understand Docker brings immutability. Okay, so and technical theoretical points I'm looking brings immutability. What next? And the next thing is yeah, all right, I think we can just go ahead and so talk about the containers basically. You can start with containers, running the containers, installation and other things. Yeah, so basically any container technology, you're going to have two things basically. Okay, so first of all so any container software will have two types of any container software will have two types of any container software will have two types of what we call any container software will have two types of what is that? Two types of runtimes. Okay, so one is high level runtime and low level runtime. High level, low level runtime. So any runtime you take it, okay? Any container, rather than saying container software, I would say container runtime, okay, will have, so we'll have two types embedded. Okay, don't so don't think that those are two basically. So it's actually same. Okay, any runtime basically. What is runtime? I'll talk about that. Okay, so now any container runtime will have two two types embedded basically. That's been the operations actually categorized. I mean, let me put it this way: any container operations or any container runtime operations are so any container runtime categories or any container runtime operations are actually categorized as a high level runtime and low level runtime. Okay, so yeah. Now low level runtime everyone will provide basically. Low level runtime everyone will provide, but yeah, so high level runtime is something like you will be coming with more features. Like APS is one of the one which is extended by the Docker, which we call it as high level runtime. So low level runtime is basically so something like create a container, start the container, okay, stop the container, delete the container. Certain operations are quite common. You take LXCs, RKTs, so these are quite common. Create a container, delete, all these operations will be coming out of box, and those are more into the low level container. But so Docker is actually a little bit rich in high level runtime. So like offering the APIs, and the imaging layer is much better. Like so even dealing with the images is much better. Okay, so certain high level runtime features are better in Docker. Okay, so than in other things. So that's also another reason. So which Docker is famous. And I'm purely talking about runtime. So basically, so what is runtime basically? Okay. So what is runtime is your Docker actually is comprised of multiple layers basically. Okay, so your Docker layer is actually comprised of multiple layers, and that is where okay, so let's talk about the multiple layers. But how can I make it? Or I think simple diagram is also fine. So you're going to have Okay, I don't know. I don't want to waste some time. So here you're going to have a Docker, so client basically. First layer you're going to have is a Docker client. All right. So Docker client will talk to Docker daemon. Okay. So Docker daemon is a service running, right? So daemon running, and this Docker daemon will talk to the runtime, which is container D. Okay, container D is actually the runtime. So which container D is the runtime which is used by Docker. And you will clearly see that, while you're installing the Docker, actually container D is the one software which is trying to get it installed as well. So Docker client is one thing which you're going to have, and Docker daemon. So to run this particular, Docker client to connect to that, to create the containers, it uses some service in the background. If the service is running only, you can create some containers. Okay. So, and and then container D. Okay. So this is the one way of setup basically, and you need to understand here the container D. Whatever I'm talking about is that container D. Okay. So now here we talked about container D runtime. Okay. So here any container runtime, and here it is a container D. Docker uses container D. Okay. So here if I just go and give high level and low level, high level and low level container runtime. If I search from the internet basically, so you probably kind of find this. Yeah, you see this diagram. This is the right one I'm looking for. Okay, so you have different containers like so runc, CRIO, container D. Container D is actually falling more onto the high level part. Okay, so whereas the others are actually more falling under low level part, or CRIO is in kind of in between, right? So container D actually, so more high level, it comes up with more features. Yeah, you see this diagram also. So more actually it is on the container D, or sorry, more the features it is on high level, it's actually having more features. But if you take here, you see this RKTs or LXCs is more falling under low level. RKTs also is not reaching where the container D is actually reaching. Okay, so it has high level and low level together, but still you see this. And LXC, you see this, it's more of a run level. Okay, it doesn't have any high level features. So that's the difference basically. So the runtime is making. Okay, so container D is the runtime, so that Docker uses, and actually it does both the operations. Low level it does and high level it does. And so for okay, so but it is more onto the high level part. We just need to understand that. Okay, and so that's how container D is the one which is being Docker is kind of famous because of these particular things as well, technically talking about. Okay, so high level runtime and low level runtime. Okay, so container D is the runtime. Okay, all right, and the next thing is and the next thing which we have here is let's go on to the practical part mostly. I think theory wise these are the things. Okay, so now whenever you install the Docker, so you'll be having Docker's client, which is Docker command, and systemctl start Docker you do, that's a Docker daemon, and actually you give Docker run and you create a container. The one which is actually creating the container is container D. Okay, so these are the things which you have in the Docker system to understand in the background. Okay, so let's go down to the practical part. Okay, so how to so first starts with the Docker images. So while we start with Docker, so first of all Docker images. Okay, why Docker images? Okay, to run any container you require Docker imaging. Okay, so to run any container, okay, so container to run any container, okay, or Docker container, to run any Docker container. Let's come to Docker, very particularly about Docker. To run any Docker container, okay, it means it needs an image. Okay, so that's the reason. Let's go and deal with the imaging first. But first of all, Docker installation. Okay, here Docker installation is also two types basically. Okay, so Docker installation is of two types. Okay, so Docker by default works with only root user. Okay, Docker. There is problems with the Docker. Docker, okay, runs by default with root user. Docker run by default with root user. Okay, if you give privileges, if you give permissions to the normal user, and if you give okay, I mean, like let's put another point. If you give permission to normal user, then if you give permission to normal user, if you give permission to normal user, then what? If you give permission to normal user, if you give permission to normal user, then okay, he gain most of the privileges of the user, most of the privileges as root user. Okay, if you give a permission to a normal user, he gain most of the access even without a sudo. Okay, so sudo is the one which you are giving the privileges, but Docker actually giving a normal user access is also you kind of giving the privileges. Okay, so this is this causes security breaches. This causes serious security breaches. Okay, so and this causes serious security breaches. And and the next thing, so which so to avoid this, basically, so to avoid this, there is a rootless installation, which we call it as. To avoid this, there is a rootless installation. Okay, so where normal user can okay, so normal user can install normal user can run containers even without even without root. Okay, so this solves the security problems. This solves the security problems, and people want to go with this. Okay, so mostly. All right, so this is how you can also have some rootless installation also. There are types of installation. I'll show you both. Basically, how do you do that? Okay, so let's go with the Docker install. Okay, so Docker install and Docker install. How do you do that? Is call -s https get.docker.com/bash. Okay, so this is how you install Docker. /rootless. And this is how you install rootless. Okay, so there are two types of installations. One is Docker install. You simply do that by using their script only, Docker script only. You don't want to really run some commands and do that. So that's a script offered by Docker. I will just so deal with that. That's directly. Okay, so let's go and try to do this. Okay, so let's start with here it is. So here is So now here, if I want to install call -s, I think we already installed Docker here. Docker.com by sudo dash. So for running that, load runner script, actually we installed Docker already in my workstation, I believe. But let's see. Okay, so I think it's already there, so you can see that, and you can just go for yum list installed for Docker. You can see this even rootless also I tried actually here. Okay, this is just the installed one now. Okay, I tried the Docker rootless also on the system, it seems. All right, that's okay. So you can see this, you're having a Docker CE and Docker CLI. So this is the daemon, okay, which is installed, and this is the CLI, okay. And whereas this is the container D, which is the runtime. All right. And if you want to, just use Docker PS, I think I already gave everything. Let me take a new machine and do that. Please. No. Call -s tps://get.docker.com by sudo dash. So yeah, just installed things. All right, and so the next one is sudo systemctl start docker. Okay, if I give docker ps, you will not get the things which are running. But if I give sudo docker ps, you get that is running. Okay, so that means if I give a root privilege to this particular, if I give a privilege to this particular user, so this user can gain some root related information. Okay, or root related access, he can gain it. Okay, so which I don't want it, so that is the reason. So we can go with the rootless also. So now how can I install the rootless? So this is /rootless. For those also they are providing the script refusing the install as a root user. Yeah, no need to give sudo bash. Okay, and what it is telling is you just need to installing Docker, missing system requirements, run the following commands to do that. Okay, so it's actually looking for some configuration file. Just do this. But actually it requires permission denied. Yum install, how it happened? Okay. So now I will just go and give +5 bash. So couldn't find the stable records for CentOS in sub-UID. So add him the details. So then you run it. Permission denied. Sudo will help. No. Yeah. You add this content, which is fine, and then you go with again. So this file is there. Couldn't find the records for the current users. Make sure it's there. Example. What's going on? I don't know. Couldn't find the record for current user CentOS from this file. Make sure the valid sub UID range is set there, and that is there, right? Oh, the file is not there. What? yeah, now it's done. So yeah. So what it is telling is you just need to export these two commands so that it can work. Okay. So you can just paste those two commands and just do docker ps. As a normal user, you should be doing this. And actually it is telling that, so this is where then, this one. Okay, we need to start the Docker. All right. So what you need to do is system did not detect Docker needs to be started manually. Okay, so this is the script I need to run to start the Docker. Okay. So if I want to run the Docker script, Docker D, basically Docker hyphen rootless.sh, Docker D hyphen rootless.sh. Okay, redirect output to /tmp/something log and just ampersand, put it to background. Okay, now you go and give docker ps, it's actually running. So I think something I missed it out, or I installed Docker on this earlier. So the Docker system ctl hyphen user start Docker. You can also do this actually. Something is wrong actually. I used the rootless and as well as the root. Something else is going on, but yeah, whatever it is, just to give you the story, docker ps. So now actually as a normal user, I'm dealing with my own container. I'm not actually talking to the root, or I will not get the privileges of the root user. So this rootless installation is also there. Just keep in mind, but we go with the root installation only. So since we want to run the software, so we always try to go with the root user. And if you want to think about the security a bit more, so then rootless comes into picture. Okay, so whatever it is, it's fine. Let me go back to my workstation. So we already have something given here, so that's where I just give docker ps. It's already working normally for me. Okay, now come back to the points. So first thing, what we're actually going to discuss here is Docker images. Okay, so first of all, if I want to know that, so what are the images which I have locally installed in my system, so then Docker images. It will tell you what are the images which you have in your local system. So at least I have some roboshop RS load which we are using it, right? So yeah, so that image which you are having it. Docker images. All right, so Docker images to give you the list of images. Now let's say if I want to download some image, okay, then what I have to do is, and where you have the list of images, by default Docker actually goes for hub.docker.com, and every one of you try to sign up here. So hub.docker.com, so it's a free sign up available. You can just go and sign up into this. Already have my account. So, and you can put your own images out there, or else you can start searching some images as well, which is by default here. So like, let's say some sample, or like, let's say you're looking for nginx and you are having nginx image. All right, so yeah, if I want to pull the nginx image, so docker pull and just give nginx, and it actually pulls the nginx image to your local system. So where your local system is now ready to run the nginx containers. Okay, Docker images. Now since you have nginx image, now you can run the image nginx containers basically. Okay, that's the idea. And so how do I remove some images? So if I want to remove the images, so docker rmi remove the image, and you just give the repository name and the spelling mistake. Docker rmi nginx, and you go and give Docker images. Now you don't see that particular image. So this is the ecosystem around the imaging part. Okay, So Docker images to list the images, Docker pull to pull the image, Docker RMI to remove the image. Okay, all right. So the next thing, so what you have here is once you have the image, how do you run your containers? Okay, so that is where the next thing comes into picture. What are the things you learned here? So Docker, so images and Docker RMI, Docker pull the image name and the Docker RMI image name. Okay, but there is something else more actually you need to learn here. So that particular thing is the next thing, Docker image versioning. Okay, so Docker image versions. Okay, so any Docker image you pull, any Docker image we pull, we have some pull that image have certain version. Okay, so by default it pulls latest image. By default it pulls the latest image. That version actually is also called as version image tags. Okay, any Docker image we pull, that image will have certain version. By default it pulls the latest image. Okay, so in Docker terminology, that version is called as called as tag. Okay, so is the default tag that Docker image uses. All right, so this is what you have. Okay, any Docker image we pull, that image will have certain version. By default it pulls the latest image. In Docker terminology, that version is called as tag. Latest is the default tag in Docker image. Okay, so now if you want to put a particular particular version, and you can pull that. So now if you see here Docker pull nginx, it's actually pulling the tag latest. So if you want some other version, then you'll be using that particular version. So Docker images is still same now. Docker pull image now colon tag comes into picture. Docker RMI colon tag also comes into picture. Okay, so yeah, and that's where Docker images, you see the latest. And Docker pull, like let's say nginx colon 1.16 is the some old version. If I try to pull it, so now it's actually pulling 1.16. So nginx version, which is 1.16, actually come from this. Okay, so this is how you deal with the tagging of this one. Okay, so tags are used for tags are used for software releases. Okay, so tags are used for software releases strategy, basically, right? Okay, so like every company will be having, or every product will be having some versioning, right? So now Git tagging you're talking about, that same tag actually comes as a Docker tag also. Now the code of the tag is there, and the image you have the Docker tag. It's quite so relation, right? So that's how this makes okay, so this is what we are having. All right, so the next thing is next thing is how do you run a container? So once you have an image, okay, so how do you run a container? So basically, so docker run nginx. So then it's actually running, pulling the image. Basically, if the image is not there, and it is trying to run basically. Okay. Now you see this is actually coming into my terminal. Okay, I don't want to attach to my terminal, so usually I go with docker-d nginx. So that means it actually launches the container. It actually launches the container in the background basically, and you can check those containers by using docker ps. Docker ps is going to show the docker ps is actually going to show the containers which are actually running inside that particular system. Okay, so docker run. Okay, so docker run, and if you want to run it in a detached mode, the first thing is docker-run -d nginx, and to list the containers docker ps you have. Okay, and yeah, so more scenarios. So probably the scenarios you can so talk about one by one in tomorrow's session. Probably I think we have some more time. Yeah, that's okay. So let's try to talk about what all the things which we are going to talk about in tomorrow's session. Basically you're going to deal with so docker port exposing. Okay, you run the service nginx as a container in your system that is accessible only inside the system. If you want to access it from the outside world, how do you do the port expose? Okay, and so the next one is docker what we call docker so volumes basically. Okay, docker volume mapping. Okay, let's use volume mapping only. And how do you use some persistent storage for docker? So why you require persistence, we'll talk about that. And the next thing is volumes, and the next one is resources basically. Docker container resources. So how do you limit your container to go with only, like, let's say 500 MB of RAM or 250 MB of RAM? So how do you say that? So or you must use only like so 10% of the CPU. How do you say to a container? So this one. So this is the other one, and mostly the other one is very important. One is health checks when it comes to the application. So health checks. Okay, health checks. And once you understand this, so you probably end up with using Docker imaging. Okay, so using those particular concepts, so you're going to start Docker images, and we have something in our requirement, right? So which is RoboShop projects. So for the project, what all the images we can make it. So we'll learn some basics of imaging, and then we'll move on to the other parts. Okay, I think mostly that's all from my side for today. Okay, yeah, any questions? Docker is a very simple concept. Okay, so you don't to put much effort on the Docker, and so because the much efforts will be keeping on the orchestration layer, which is Kubernetes. What is Kubernetes? Why Kubernetes? Also, we'll talk about that, and yeah, so you will understand that. And whereas when it comes to the orchestration, so you basically you learn more on the orchestration layer rather than actually wasting the time around the Docker. And actually, in current version of Docker is, or sorry, Kubernetes.io. And so if you go to the documentation, the current version which you have here is so 1.20 is already released. Okay, so from 1.20, so containers will not support, sorry, Kubernetes will not support even Docker. Okay, you don't really require, if you are actually taking a line of Kubernetes, you don't really require to go and waste your time around the Docker. So you can directly Kubernetes does not support Docker. Okay, so starting from version 1.20. So what is the statement here is yeah, so Kubernetes is deprecating Docker as a container runtime after 1.10. Okay, so this is basically for the older versions of the Docker, like let's say very older versions of the Docker. I mean to say, like if you are using Docker, currently the Docker version which you installed here. So this is 20 version. So here you don't have any problem basically, and let's put it specific. So they're actually trying to replace the container D with something called as CRIO. Okay, so CRIO is a container runtime from the Kubernetes. So they are trying to put their own CRIO, but CRIO work with Docker imaging again. You can pull Docker images and you can still run container runtime with the Docker imaging. So, but it's their own container runtime. So that's the reason actually you don't really so spend time around Docker as well going forward in general. But yeah, so still in some days you require some knowledge on Docker, and Docker is quite basic only. It's not a big deal. And I think that's all from my side for today. Any questions?
Raghu, for the purposes of us installing, you said that we should install the Docker root version, right?
Yeah.
Okay.
So unless, I mean, there are certain things, if you want to deal something on the system level, you require root privileges, or let's say you want to run only on yourself, you don't require some system level access, like, so certain mount points and all. Yeah, you still go with the rootless is fine. Okay. So, but if you want some information which is held by the root, in that case, you go with the root thing. And by default, at least the Kubernetes even uses the root installation only, not rootless at least to start with. Yeah, but there are other ways actually. How do you handle that as well? But yeah, on the high level Docker, this is what you have.
Do you share these slides, Raghu, or this is personal?
Yeah. End of the sessions, I'll share this.
Okay. Thank you.
Yeah. Okay. All right. The questions we'll meet in tomorrow's session then. Okay. Good day. Good night.